Welcome back to my Catia V5 tutorial. Today we're going to look at how to design joggles on flanges, join them cleanly to the rest of the part, perform complex 3D trims, and experience firsthand how easy it is to go back and radically change surfaces inside our part, provided we've built our CAD model correctly. So let's get to it. Okay, we're gonna start by designing this vertical wall here, and we're gonna do that by creating an offset from one of the planes, the ZX plane, and then creating a sketch on it. We're gonna create a simple sketch, just a line, horizontal line, and we're going to extrude this line up to create our surface. So we choose Z, we make sure it's long enough, it looks fine, okay. Now, we need to rename this and call it Y surface, because it's a surface in Y. Just one thing, need to change the render style to parallel. Okay, this looks good. We create another sketch on this. This is so we can create the small depression here at the end. And we quickly make a line, which we fully constrain. And we're gonna use this line as a starting point for this little joggle. Then we're gonna sweep this line at a 45 degrees angles with regards to the base surface. Then we're gonna offset the base surface that we did by a tiny bit, 1.6 millimeters should be enough. And afterwards, I'm just gonna fillet these together. This way of creating joggles is kind of like an algorithm, so make sure you remember this really well. Okay? And that's how we created this little joggle step here. So remember this procedure because we're gonna do it a lot. Line sketch, sweep, offset, and fillet everything together. That's how we create joggle steps every time. Make sure the orientations are right. Okay, good. Okay, now we go into the next set. We call this Weld Flange. Defining work object, create another sketch. This time we're gonna go with the ZX plane directly, and we're gonna draw this shape in a sketch, fully constrain it. It's just a straight line segment followed by a arc circle. Right, we're gonna extrude this in the Y direction, like that. Okay, now we take the first line that we created and intersect it with this newly created surface, and we get a point. And we take that point and then basically create a line in the Y direction. We could have just used the sketch for this line, but sketches are among the most unstable elements in Catia. So that's why I prefer to use a 2D wireframe like the line. And we're gonna use this as the starting point for our little depression there. So we take this again and we sweep it with draft direction this time. Choose the draft direction, the Z direction, or you can just choose this plane. Okay. We offset the first surface by another 1.6 millimeters, and we fillet it again, the same as we did with the other flange. Alright, we make sure the directions are okay, and now we have two surfaces with this little depression inside them. Now we go to the next set, rename it to nut flange, and we're gonna draw this this surface here that contains the weld nuts. To do this, we're gonna first make some points in space, which are going to be the centers of the holes, and we're gonna design everything to them. Okay, that looks fine. We're going to create a line between them. And we're gonna extrude this line. And that is the base surface, where the nuts are gonna sit. Okay, now we have this little depression between them. We create a sketch on the ZX plane again. We project the points, because we're gonna use them, and we just create a simple line. And we're gonna constrain the line ends to those points. Okay. We extrude this and take the edges of the line and sweep them down to create those slopes. It should be probably a lot longer. Okay. Okay, that looks good. Now we fillet this shape together. We're treating this surface as a complete flat surface with a bump in the middle, and we're setting ourselves up to add the bump with a single fillet operation. 5 millimeters seems a bit low. Let's go with 8. Yeah, 8 seems better. Okay, now we do the last fillet between this shape and the base surface. 8 again, and looks fine. But there's a problem here. This top weld flange here would not be parallel to Y. But we're just gonna move on and fillet the surfaces together and pretend we didn't see it, and I'll show you how to fix it afterwards without destroying the whole part. So in the final part geoset, we create fillets between these surfaces, one by one, making sure the orientation is right, of course, and the radius looks realistic. So for this one, for example, I'm gonna go with 8. That looks good for now. However, we still missed this little depression here in the top, and we still have the issue of the flange orientation. What we needed to do is to have an angle on this. So starting from that point, I wanted to have an angle towards Y. So we go back. That's very easy to fix. We go back to the weld flange. We create an intersection between these two surfaces, between these two extrudes, and then we sweep this line with draft direction, give it a small angle, but it has to be a lot longer than this, so 150 millimeters, yeah, 100, 200 and 100, yeah, that's pretty much better. Right. Now this step is optional. You can right click the set and choose reorder children to move the sweep and the intersect closer to the previous surface that we used, which is the extrude. So just move them after there, and then we right click the extrude, replace, and choose the new sweep. Make sure the arrows are pointing the same way and click OK. That should automatically update the part. If you hide the construction set, see, this surface here is angled, but we have a problem. The step doesn't look too good. That's probably because when you sweep this line, that's how it intersects the new angled surface, and that's a problem. So we go back to the line, select insert mode to replace the line. Okay, now we project the line to this new angled surface. I just need to find it. Yeah, this one, the sweep. And now the line will be projected on that surface. We have an error here, but we'll worry about it later. First, the projection needs to be along a direction and along the z-axis. That's better. It's probably the same thing, but just need to make sure. Now, to try to update it and see what's wrong. So we get this error here on fillet 8. So what is the issue here? I need to check this. It looks like it's not filleting these surfaces together well, and it's probably because of this intersection here where we have the overlapping 4 radii. Yep, that's pretty much my guess, that that doesn't work. Let's try this easy fix. We're gonna go to one of these radii here and change it from 5 to 6 and click update. And what do you know, that worked. Something easy for a change. Now this surface has a joggle on the other end. So first we need to just hide all the stuff that we don't need and collapse the tree a little bit, and create another sketch on this plane and create another line. And we're gonna use this line as a starting point for the joggle. Now where is that surface? This one. We're gonna use this sweep and we're gonna project this line onto the sweep in Z direction, just like that. And then we're gonna sweep this one with the draft direction in Z at a 45 degrees angle. This will be our joggle surface, and we're gonna offset the sweep and then fill them together just like before. This is what's important: learning frameworks for building proper part structure. 5 millimeters should be fine. And this is the basic algorithm for creating these small depressions. Right, do the final fillet. That's good. Now I just update everything. See, because we used insert mode, it automatically updates the result. So we generated 3 juggles, and the technique used for the line was different in all 3 times. Okay, next up, we go into the Y surface to create that little shape at the front. Or back, depending how you want to build this part. So we create another sketch on the ZX plane. This time it's just an angled line. Make sure we fully constrain it. Okay, and this line we were going to sweep. This time it's not going to be a draft direction. We're going to go with the reference surface. Yeah. Let's go with 2 degrees, maybe a little bit more. Maybe 3. Yeah, that's probably better. A little longer, and maybe 50. That should be enough. Okay, we create another sketch here now, and this time it's going to be another angled line. It's going to be nearly 90 degrees to this one. Control it a little bit better. Okay, and we are going to project this line onto the sweep. It's going to be a Y projection. I always like to project along a direction wherever possible. And then we're going to sweep the new line again with the reference surface, using the sweep as a reference. And then we're going to fill them together, and this is our depression. And we're going to use this to fillet it back to the main surface. We take the last surface that we created, make sure we define it in work object. We select insert mode again, and we fillet it. Okay, that looks good. We'll update the final part and check how it looks. Exactly how we want it. That looks good. Okay, go to the next geoset, rename it to lower flange, and then just start a sketch on this plane and start drawing the outer contour of this part over here, just where we have this flange going down. Make sure to fully constrain it so it doesn't jump around later, and that looks pretty good. And this one we're gonna sweep with draft direction this time, using the Z-axis, or using the Z-axis. Probably gonna be something like 6 degrees. It needs to be much taller so it intersects the whole surface. No, not tall enough, yeah, just a little bit more. Yeah, that's fine. Okay, go back to the final part, and then we're gonna fillet this to the rest of the body and see how it looks. Not bad. I think this is exactly what we wanted. Okay. Perfect. So this is our base surface. We just need to trim it and put some holes in it. We create another set, we call it trim, and inside the set we create subsets. We're gonna call this front trim, and here we're gonna start sketching the front of the trim. We just need to worry about the edge to the left, because we're not gonna use the right edge. We're just gonna use it to connect it to a different surface. Right, make sure we constrain it well. Okay, this corner here we can make it as small as possible because we're not gonna use it. Right, now we extrude this in Y and start working on the next sketch. This time we do it on the XY plane, which is this one. A sketch from above, and we trim this corner here like that. we constrain this as well. And we extrude this sketch in Z. Good, that looks fine. And then we're gonna fillet these two together and hope for the best. Five millimeters radius. Yep, that looks exactly perfect. Maybe this is a little too long. I can trim it back a little. It's not really that important because it doesn't intersect the surface. Okay, we create another geoset. Call this one rear trim. And do basically the exact same thing that we did in the front, just do it in the back. Or rather the other side. Again, not sure which is the front and which is the back. So we create this sketch again. The top surface, top line is gonna, the forward line is gonna be angled this time, from what I can tell in my reference picture. Okay, we extrude this in one direction, and then we create the other sketch. Make sure we constrain it well. This just trims that little part of the corner there. We extrude this in Z, and then we fillet the two together. Okay, make sure you get the orientations right. Yeah, that's good. Okay. Front and rear trim done. We need to create the bottom trim now. So create another geoset, call it bottom trim. So we create another sketch in the XZ plane. A lot of sketches for creating the trim. It's my least favorite part, but it has to be done. We create this shape over here. We could have just offsetted the surface on the top, but I have a feeling that those small radii there wouldn't have offsetted really well. This way we can control it better. We extrude it in Y direction. One thing I forgot is to change the color, so we know it's something different. So we create another set, this time for the top trim, which is going to be extremely simple. We create another sketch, and this top trim is just a line. Constrain it and extrude it, and we're done. Now in this trim set, we're going to create yet another set. It helps to keep things organized, and call it final trim. And here we're gonna just fillet all these portions of the trim together. So one by one, just like we do in the final part, but this time we'll do it for the trim. Cool. That looks good. Now we go to the final part and create a split from our base surface with the trim. And this is our part without holes. Now we go back to the construction set, create another geoset, call it holes. Here we're going to maybe create points at first. And on these points just create a plane. Parallel to point. Yeah, we're just gonna go parallel to point, and we're just gonna pick the XZ plane as the parallel. Okay, and create a sketch on this, and here we have the option to create this elongated hole like this, which is most of the times used for referencing. Yep, that's fine. We extrude these in the Y direction, and for the two nut holes we're going to create two lines tangent to the surface in those points, and we're going to create a sweep, this type of sweep with center and radius. Just select the center curve and the radius, And then we have our 2 cylinders. And now for our final operation, we go to the final part and trim our surface with the holes. We can do this in only one operation, and then switch the workbench to body, go to the part body and give it some thickness. Now we can go ahead and hide all this clutter that you don't need. And that's how you design this part. And just like that, you've just mastered joggles, tricky 3D trim and smart surface editing in Catia. If you enjoyed this video, make sure to check out one of these ones next, and make sure to let me know by commenting or leaving a like. Thanks for watching, see you next time.